Hello everyone, welcome to my final project presentation for Educational Technology class 2018 spring semester. And my topic of final project is for machine learning analysis on student exam performance following a research track. So here, let me give you a presentation overview first. To begin with, I will give you guys a introduction and background. Secondly, I will introduce the research motivation and goal. Thirdly, I will introduce the research methodology. And finally, I will discuss the research results from my experiments. So here, let me give you the introduction and background. So there are already a lot of research being done or already done in the past by other researchers for exploring many factors that could affect the students' performance in exams. For example, Mark, in her paper and research, has pointed out that the significance of teachers' quality and supply will generate a huge impact on the students' performance in the exams. And on the other hand, Sama and Carter's research gives a more comprehensive review on a series of factors that might affect students' performance in exams. And they have categorized those factors into four categories, which listed here: extrinsic factors, intrinsic factors, personal factors, and other factors. So as you can see in the table on the right, for example, the shortage of time is categorized of extrinsic factors in the exam. And the other things such as physical health will be categorized as intrinsic factors for students' performance. So here is my research motivation and goal. As I mentioned earlier, based on the previous study, there are so many factors that might impact students' exam grades, such as the school ranking, home environment, family, and other factors, etc., etc. So it becomes very, very difficult to predict a student's exam performance given so many factors. But in the meanwhile, it is also very important to do it correctly because that will significantly help the teachers and parents to help their students or children to improve the performance in studies. So the goal of my research is to select a bunch of candidate machine learning models and evaluate their prediction performance over the exam outcomes from the students. And in the procedure, I will tune the parameters so that they can reach their best performance. And I will also retrieve the best model for the teachers for their use of prediction on the students. So here is the methodology of my research. The data size I select for doing the research is a bunch of student examination performance data points acquired from UCI machine learning repository. And all the machine learning algorithms and analysis are being done using the VCA 3.8 macOS version, which is a GUI tool for doing machine learning analysis. You can download it from the internet. And all the graphs, including learning curves and tables, are plotted using Windows Office Excel 2016 after I collected all the results from VCA GUI and the dataset. Last but not least, each model will be evaluated based on the tenfold cross-validation accuracy and testing accuracy to eliminate the bias and overfitting of the model. And on the right is a visualization of my data sets using the Weka GUI. So here is the demonstration of all the research results that I collected, and here are the 6 graphs, which are the learning curves of different models I have tried in my analysis. As you can see here, I used 6 models, which are neural network, decision tree, KNN, which is a nearest neighbor, boosting learning, and SVM, which includes polykernel and RBF kernel. And as you can see here, the best performance of all 6 models are pretty close, which is around 88% to 90%. And that is pretty good, actually. 90% is a pretty high prediction accuracy for students' performance prediction. And another interesting point we can observe is all the model accuracy starts to drop after a certain threshold, which is around 80%. So the x-axis represents the percentage between the training set and the testing set. So that indicates that there might be some noise in my data set, which causes this drop of performance after certain percentage of increasing the size of training set. So here is a summary table of all the models I have used, and the highlighted rows with yellow are the best models I selected for the final prediction, because they have the highest tenfold cross validation and testing accuracy, which is above 85%. But there's another interesting observation here, is that actually the data sets I selected actually requires simpler models to achieve better performance. The complex models such as neural networks actually doesn't perform very well, because as you can see here, it only have 85% testing accuracy. So here are some discussions based on the research results I collected. As I introduced earlier, the best performance in prediction is around 90%, which is a pretty satisfying and reliable result that indicates the approach is doable and feasible for real-life appliance, and also it can benefit the teachers and parents to help their students. And another point is, too complex model might actually overfit the student's performance data set, and therefore perform worse than other simpler models, as I shown in the previous slide. And that also indicates there is certain degree of underlying correlation in the attributes of data sets in my selected student performance data set, because more complex model actually perform worse, because they take much more interpretations on those correlation and overfit. So as a summary, the best models for the student performance data sets based on my experiments and selected machine learning models are decision tree with C tuned as 0.1, or the SVM model with gamma tuned as 0.01 and C tuned as 0.1. And that's all for my final project presentation. Thank you for watching my presentation. For more details, please refer to my final paper. And there I have included all the results and all the more detailed analysis in the paper. Thanks for watching.